Now that you've finished machining your step bar, we're going to actually inspect your parts. This goes for all parts, but today we're specifically talking about the step bar. So first thing you're going to need is your grading print. So this will look just like your normal machining print, but it'll have some extra information on here that will go along with your grading sheet. So 2 sets of A through Z on your grading sheet. And then here's your non-conformance report, and I'll show you how to use this if you need it. So set that aside for now. We need this guy and this guy. So first thing we need to do is we need to identify what are measurements that come from our part, where they relate on this print. So A is the overall length of this part. So I'm going to use a set of calipers, and I'm getting 601. So we come to our sheet. On this first half, obviously you'll put your name, the part name, so this is the step bar. So for A, should be 6 inches. I'm the student in this case, so 6 inches. Or actually, we got 601, didn't we? And our tolerance for 6 inches is, it says plus or minus 10 for a single decimal. So plus minus 0.01. We're in spec, so that'll be fine. Next, let's check all these diameters, and then I'll go back and check each 1 inch. So for the diameters, I'm going to use a set of micrometers just because it's more accurate and it'll be quicker. So our M diameter is our smallest one. So see these extension lines? So M is our first diameter, and we're aiming for the 3rd decimal. So 3 X's, that's the 3rd decimal place. We are plus or minus 5 thou. So if I put my micrometers on here and I come down to my sheet, so I don't care about tolerance right now, I want just your student check, and we'll say M is 0.6256. If you're measuring with micrometers, obviously I can get down to the tenths. If you're measuring with calipers, those are only accurate to 1,000ths. So then we'll go to L. .7503, and make sure this is legible. And then K, dang, what happened to my K? 0.8771. And then we'll go to D. I guess that's as close as I'm going to get. Or this is J. 0.999. And then because these are 0 to 1, I have to switch to a different set of micrometers. So here's my 0 to 2s. So it should be 1 inch, and this is I. So it should be 1 inch and 8. And I got 1 inch, 127 6. Looking at my veneers, yeah, go with, lines up with the 9. And then we'll look at our H step. So 1 inch, well, 1 inch, 2, 50, and then I'm past that, so now I need to go to my veneers. 252. So I got 1 inch, 250, and 2/10. So that's how we're going to measure our diameters. For our steps themselves, the most accurate way to check them will be with a height gauge. So I'll move you around here and I'll show you how to use the height gauge. So using the height gauge, we're going to use this wheel at the back, slowly bring it down, and we're going to have it to where it just, when you start to feel any resistance, it's touching the table. We'll zero our dial. So this piece here can swivel. So we'll make sure it's facing at 0. And we might do that twice just to double check that our feel is calibrated. So once we do that, we'll zero off our actual dials here. And then we're going to go to the top of our part. In this case, I'm just going to the first step since I can double check the overall length here just to make sure my calipers were right. So I got 6 inch on the nose, which is what my caliper said. So let's go back to the start. Or not to the start, but to the first step. So the first step, just put the tip on it. So it looks like I'm 1 inch and 6 thou. So if I look at the print, that is dimension B. And because dimension B is a single decimal place, we can use plus or minus 10, so I'm still within spec. So we're going to write that down. So B is 1.006. Yep, 6 thou. Now, because the steps are measuring from here to here, not from here to here, I'm going to re-zero my gauge. So zero it, zero those two. Now we need to go up to the next one. It'll take a little bit of feel to know when you're not on the radius of that shoulder where your tool left it. And also, if your part rocks at all, this part will be really difficult. So I think right there is an accurate number. And so for step 2, I'm 1 inch, well, I'm not quite 1 inch. I'm 995 thou. Write that down, re-zero everything. Back to the top. Well, not to the top, to the next one. So I'm at 1 inch and 4 thou this time. So that's dimension D. So 1 inch, 004, 0, 0. On to the next one. Uh, 96 thou this time. So 996. Zero it off. Close on this one. So 1 inch and 2 thou. And it's really easy. If you watch the bottom right here, you shouldn't ever lift the height gauge off the surface plate. So for example, that's using too much force, and now I can get a piece of paper under the front of this height gauge. So that measurement is just wrong. So you need to make sure that you're only touching the part. So re-zero everything off. Ooh. Guess I could have been a little more diligent on my lengths, but we had quite a bit of tolerance to play with on this first part. So my G measurement is 992 thou. So that's how you inspect your part. There's nothing complicated with it. You're just measuring what you've already cut and making sure it lines up with what's on your print. I will show you how to use your non-conformance report though. So on this particular print, all of these lengths I have plus or minus 10 thou, which is fine. Let's for a second pretend that I have plus or minus 5 thou. That drastically changes my results over here. So now if I have plus minus 5, 5 not 50, on here to here, now just going down the line I can see this one's out of spec and this one is out of spec. So now that I've tightened up my tolerances, I have two measurements that are out of spec. So that 995 is right on the edge of tolerance, because it's, if I have plus or minus 5, I can be 1 inch in 5 thou or 995 thou. That would be my window. So let's look at how we would non-conformance these two parts. So of course, top of the page, fill out all your information, student ID, description, lot ID. Don't really need all that, but it's there because this is mimicking a real one. So, description of nonconformance. So I can say on my item over here, I have to look at my print, so it's B and G that are out of spec. So B and G. Description of nonconformance. I can just write something simple in here. Does not meet spec. So it's out of spec. That's all we need to really know. The important part I want you guys to learn for this is description of rework or method to use as justification. So essentially what I'm asking for here is I missed B and G. How do I fix B and G on this particular part? Well, B on this part would be really easy because it's the last step and I'm over length. So it's supposed to be 1 inch. I'm 1 inch 6 thou. So I could easily just face off the end of this thing and be within spec. No big deal. G, however, if you remember my inspection sheet over here, I'm actually short. So my G is too short. Well, the only way to make this longer is I need to shorten here. So if I make F shorter, where was my F on here? So F was actually 2 thou over length. So could I take 3 thou from F, add it to G, and everything still be in spec? I believe so. So if I took 3 thou here, minus 3 here, that would be 0.999, and this would put this at 0.995. So yeah, that would work out, and that would put me back in spec for everything. So I would just need to write that in my description of rework down here. But other than that, that's how you fully grade a part